Section 7.1 is on the multiplication properties of exponents. Let's start with a definition. A monomial. A monomial is a number, a variable, or the product of a number and variables with non-negative exponents. A monomial has no addition or subtraction, and it has no variables in the denominator. Let's take a look at a couple examples here. First of all, determine whether each expression is a monomial, and then explain. Number 1, 16x squared y. Yes, this is a monomial because it's the product of a number and variables. Remember, product means multiplication, and this just has a number 16, and it has variables in it. It's just multiplication. Number 2, 7 divided by a squared. This is not a monomial because it has a variable in the denominator. A monomial cannot have a variable in the denominator. Number 3, 3x plus 5y. This is not a monomial because it has addition. It's actually the sum of two monomials. 3x is a monomial, 5y is a monomial. You can't add them together. Number 4, negative 6. Yes, this is a monomial because it's a number. Remember, the definition said it's a number or a variable or the product of a number and variables. And number 5, x. Yes, x is considered a monomial because it is a variable. So the product of powers says that if you need to multiply two powers that have the same base, add their exponents. The base is the big number that's on the bottom. The exponent is the small number. It's the power it's being raised to. So if they have the same base, just add their exponents. So a raised to the power of m times a raised to the power of n is a raised to the power of m plus n. Here's an example with actual numbers. X squared times x to the 4th is the same as x to the 2 plus 4 or x to the 6th. I keep the base the same and I add the exponents. Let's take a look at a couple examples here. So I have 3x to the 5th times 2x squared. First thing I want to do is multiply the coefficients. Remember, the coefficients are the large numbers out front. So 3 times 2 gives me 6. And now I have to multiply x to the 5th times x squared. Since they have the same base of x, I'll add their exponents. So that's going to be x to the 5 plus 2, or x to the 7th power. Example number 2. 2a squared b cubed c to the 5th times negative 8ab to the 4th c cubed. I'm going to treat this the same way. I'm going to multiply my coefficients. 2 times negative 8 gives me a negative 16. Now I'm going to look at my a's. A squared times a, basically a to the 1, is a to the 3rd power. Add the 2 and then the 1 that's not there. B to the 3rd times b to the 4th is b to the 7th, because 3 plus 4 is 7. And c to the 5th times c to the 3rd is c to the 8th. So just add your exponents. A power of a power. So to raise a power to a power, we're going to multiply the exponents. So if I have a raised to the power of m, and that whole expression, that whole monomial, is raised to the power of n, then I multiply my exponents. So a to the m raised to the power of n is a to the m times n power. Here's an example. X to the 5th, the whole thing raised to the 3rd power, is the same as x to the 5 times 3 power, or x to the 15th. So if you have an exponent inside the parentheses and an exponent outside the parentheses, multiply them. Here's a couple examples. So simplify each expression. I have y to the 6th, the whole thing raised to the power of 3. Remember, what this really means is y to the 6th times y to the 6th times y to the 6th. That times itself 3 times. So I'm going to multiply my exponents, and that gives me y to the 18th. Example number 2, 2 to the 3rd raised to the fourth, raised to the second. Don't worry about coming up with a number. I don't think your calculator could handle this. I'm just going to leave 2 as my base. So I'm going to leave the big 2 as the base, and then just multiply my exponents. So 3 times 4 times 2, or 2 to the 24th. Don't punch that into your calculator and try to come up with a number. Just leave it like that. The power of a product. So to find the power of a product, find the power of each factor and then multiply. So for example, here I have a times b raised to the power of m. A times b, that's my product. And if that whole thing is raised to the power of m, that's the same thing as saying a to the m times b to the m. So you can break those apart. Here's an example. 3x squared y, the whole thing raised to the third power. This little third power here applies to each part of that. So that's 3 to the third power, x squared to the third power, y to the third power. And evaluate each one of those separately. 3 to the third power is 27. X squared to the third power, multiply and get x to the sixth, and y to the third power. And here's a few examples. We're going to simplify each expression. So I have 6xy squared, the whole thing squared. So that's going to give me 6 squared. Now be careful here. A lot of people think I can just multiply and I'm going to do 6 times 2. Well, no, you can't do that. What it really means is 6 squared. 6 times 6, which is 36. The only thing you can multiply are the exponents. So that's going to give me x squared, and y squared squared is y to the fourth. Number 2, negative 3x squared y z cubed, whole thing squared, times 2x y to the fourth, z to the fifth, whole thing cubed. So I'm going to do each one of these separately. So negative 3 squared gives me a 9. X squared squared gives me x to the fourth. Y squared, z to the third squared, z to the sixth. Now I'm going to multiply that by this expression simplified. So 2 to the third power is 8. X to the third. Y to the fourth to the third power is y to the 12th. 4 times 3 is 12. Z to the fifth to the third power is z to the 15th. Now to finish this out, I have this monomial times this monomial. So I'll multiply the coefficients. 9 times 8 is 72. And now remember, when I do x to the fourth times x to the third, I'm going to add the exponents. Y squared times y to the 12th is y to the 14th. And z to the 6th times z to the 15th, add the exponents, z to the 21st power. So how do you know if you're done with a problem, if you've completely simplified it? An expression is simplified if each base appears only once. Your solution has only one x, one y, one a, one b. Each base appears only one time in the expression. There are no powers of powers. There's no exponents inside the parentheses with an exponent outside the parentheses. And of course, as always, all of your fractions are simplified.